right, we've got another definition here that's a pretty important one and kind of a neat one. So the definition is for the case where if all of the elements in a set A are also elements of a set B, then we say that A is a subset of B. It kind of makes some sense because we actually use the word subset in English on a semi-reasonable basis. And that's typically what we think about. We think about this idea of containment, if you will. So the things that are in the set are in the other set. The notation that we're going to use for this, it'll be A. You kind of put like a very long, wide, sideways C with a line underneath it. So this is read is a subset of, and then we would put the larger set. So A is a subset of B. So A is the set that has all of its elements are also elements of B. So we could look at a couple examples. Let's say that I have A is the set containing cat and dog. And let's say B is the set containing cat, dog, and goat. Well, if I take a look at this then, I could ask true or false. Is A a subset of B? Well, we have to go back to the definition to know, is it a subset? We have to check, is the definition true? The definition says, I'm going to look at are all of the elements of A elements of B? So is cat an element of B? Yes. And is dog an element of B? Yes. So it meets the definition, so this would be true. Now, an interesting example that we could look at is, well, what if, let's say I have C as the set that contains, say, dog and cat. We could ask true or false. Is A subset of C? Well, again, we would go back to the definition of subset. So it asks, are all of the elements of A also elements of C? Well, A has the element cat, that is an element of C, and A has the element dog, which also is an element of C. So yes, this would be true. It satisfies the definition. So indeed, we do have that A is a subset of C. Notice, we would also have C is a subset of A in that case, right? Dog is an element of A and cat is an element of A. So in that example, they can switch. What about in the example above? If I look at B, B contains cat, that is an A. B contains dog, which is an A, but B contains goat, which is not an element of A. So we would have that B is not a subset of A. Notice again, we can do the is not by just putting a slash through it. So there are some times where most of the time that subset has a strict ordering to it, but there are instances where you can flip it around. Notice if we look at what's true about A and C, they actually contain exactly the same elements, which we learned in the last video means that they are equal. So equal sets, by definition, are subsets. There's a little bit of a nice analogy I like to help people see where the subset symbol looks fairly similar to the less than or equal symbol, right? It has that bar underneath and it sort of has this orientation to it. So when you see the subset symbol, you can think about the numeric symbol less than or equal. Now, we don't always want to consider a case like A and C, right? Sometimes we want this idea of like a strict containment, like the relationship between A and B. So we might look at a new definition, what I have on this second board, says if C is a subset of D, so you have to satisfy the definition of being subset, and C is not equal to D, so it has a further restriction. We call that, it's a special type of subset, we call it a proper subset. So it satisfies that extra condition, that extra restriction of not being equal gets to be called a proper subset. Now the notation for that, we're going to say that C, it's like the subset symbol, but there's no line underneath. So C is a subset of D. So analogously, if we're thinking about that, like how the subset symbol was like less than or equals, the proper subset symbol is analogous to strictly less than. So some examples that we could look at, let's say that we have something like C is the set containing 1, 4, and 9, and let's say that D is the set containing 1, 9, 2, and 4. We could ask true or false, C being a proper subset of D. Well, first we would have to check, is it a subset? So we would check the elements. Is 1 an element of D? Yes. Is 4? Yes. Is 9? Yes. And then further check, are they equal? Which the answer would be no, because D contains 9, or excuse me, D contains 2. And 2 is not an element of C. So this would be true. If I created another set, like let's say I had E is the set 1, 2, 4, and 9, then we do a true or false of is E a proper subset of D. Well, we would check if it's a subset. 1 is there, correct. 2 is there, correct. 4 is there, correct. And 9 is there. So they are subsets. This would be true, but if we double check, they are equal to one another, so this would be false. And it would be false because E equals D. They're the same set. And then we don't want that with a proper subset. Let's add one more, A, B, C, D, E, F. Let's say that F is the set containing 1 and 5. And let's ask true or false, is F a proper subset of D? Well, let's check first, is it a subset? Notice they're not equal. They don't contain the same elements. But if we check this, right, is 1 an element of D? Yes. But is 5? No. So this would be false. And it would be because it doesn't satisfy the definition of being a subset. It doesn't have every element in the subset being a part of the larger set. So this is because F is not a subset of D. There is an element in F that is not an element of D. So they're not even a regular subset, so you can't be a proper subset. Remember, a proper subset is just a special type of subset. Most subsets are proper subsets. The only one that's not is the one that's equal. All right, we have kind of a quick fact, that's a fun fact, about subsets. And it has to do with our friend that we just learned about in the other videos, the empty set. So our fact is that the empty set is a subset of every set. It doesn't matter what the set is. It's a subset of the set containing cat and dog. It's a subset of the set containing 1, 4, and 9. It's a subset of the counting numbers. It's even a subset of itself. The reason why is because if you think about the definition, it sort of trivially satisfies the definition in that it doesn't fail the definition, right? It says the definition for a subset says all of the elements have to be elements of the other set. But what do we know about the empty set? It doesn't contain anything. So in particular then, it doesn't contain anything that's not in the other set. So by definition, the empty set is a subset of every set. It may or may not be a proper subset. We'd have to think about that. But it is a subset of every set. What we're going to do next, you're going to, again, go to your worksheet for section 2.1, and you're going to start to work on the next problem. The next problem is a big list of a whole bunch of trues and falses that's putting into practice all of these symbols that we've been learning. So give it a try. Do as many of them as you can, and then as you need help, watch the next video that has the solutions. And once you've finished all of them, make sure you watch through the whole next video to see those solutions for that worksheet.